A lot of the time in an ideal gas law problem, we're actually trying to see what's going to happen after there's a change. And so we can categorize those as being before and after kind of problems. We're going to have information about how the system was at the beginning. Something happens, here's our new set of conditions, and we're going to look at that change. Now, that also means that a lot of things are probably going to stay constant throughout it. Maybe we're doing a reaction and the vessel is a fixed volume. In those cases, we're going to be able to say, hey, shouldn't we be able to cross-cancel those and not have to account for them at all? And we'll see how we do that. Now, the first thing we should do is let's go ahead and write down our ideal gas law. So PV equals nRT. Next up, let's rearrange it so that everything is equaling our ideal gas constant. It's a constant after all, so let's take all of the actual variables over to the other side. We get PV over NT equals R. Now, since R is a constant, we know that we could rewrite it so that there's subscripts on this. Our initial conditions are going to equal some sort of other condition. We can have the exact same thing rewritten, but now we can put a different set of subscripts on it. We can call it 2. And once we do that, we don't really need the ideal gas constant there at all. We can just write it simply as P1 V1 over N1 T1 equals P2 V2 N2 T2. Now, the great thing about that is, suppose that, like I said before, what if we held our volume constant through the entire process? Even if I don't know what the number is, it's going to cross-cancel. If I don't have a change in moles, I'm only looking at pressure and temperature. For a sealed system, this number of moles were locked inside of a sealed container. The sealed container's volume doesn't change. Then all we're going to have as a possibility is a change in pressure and temperature. And notice that these start looking a lot like some of the examples you'll see in most textbooks when we start talking about the named laws, like Henry's law, Avogadro's law, all of those. So we can actually bypass having to know a lot of those laws because we can set this up ourselves. Now, any of the information we have will still be true in this case, and we can use them. Now, that allows us to cross-cancel things if we know the value. It allows us to cross-cancel it even if we don't know the value, like I just pointed out, which makes it a really, really useful trick in solving ideal gas law problems.